Okay, we are using quadratic formula. You've learned this. You learned it in Algebra 1. You learned it in Algebra 2. Don't ask me about geometry because I haven't done that since I was in high school. But you've learned it. Now, when you were in Algebra 1, you would plug it in and you would type it in your calculator and you'd get a decimal, or you would say prime. But we don't do that anymore because now we deal with imaginary numbers and now we simplify radicals, okay? So we don't round decimals and we don't always type it all the way into our calculator. Remember, we're still finding x-intercept solutions, roots, and zeros, so we're literally still talking about where our quadratic touches the x-axis, except now it's not pretty. Yes? Okay. Always works even when it cannot be factored. Set equation equal to 0 before you find a, b, and c, and then use the quadratic standard form, y equals ax squared plus bx plus c. Pretty much put it in order before you find your a, b, and c. Yes? Okay, none of that's new, right? Okay, you will hear me tell you to use the skeleton, and when I tell you that, this is what I'm talking about. Every time you write this out, I tell you to write the whole thing out, and instead of putting the letters, put parentheses. Because it's missing the guts, all the important stuff, right? Our bones are great, we need them, but like without our organs and stuff, we're still useless, okay? Without the A, B, and C, this is still useless. I've said that all day, okay? Another thing, what do you notice about this first B?
It's negative.
It's negative. So what happens if I plug in a negative number? The negatives cancel, and it becomes what? Positive. So anytime you plug in B, it's going to always look opposite at the front. Okay? It's always going to look opposite right there. Yes? Okay. So those are the key things here. Again, remember we call this the skeleton. And if you need to, you can write your letters just little because you're going to put the actual numbers for those letters in those blanks. Yes? Cool. Okay, so look at number 1.
So where's that? Where's the first one say? It's like B and then what?
The circle?
No, like the parentheses.
Plus and minus.
Yeah, but like it's like B, then what does that letter say on top?
B.
B?
A. C.
Okay.
It's these letters.
So, yeah.
Uh-huh. Okay, so look at number 1. This one's already plugged in for us. Okay? And it says, what quadratic equation was used to plug into the quadratic formula? So what it's wanting to know is what ax squared plus bx plus c equation was plugged into there. So we need to find our a, our b, and our c. Now, if it's unsimplified, my word of advice is to always use under the house. It spells back. Okay, so what's your a? 2. And what's your b? 13. And what's your c? -7. So what is your equation? 2x squared plus 13x minus 7. I forgot my x. Okay, so there's your equation. Any questions with that? Okay, and then it says, what are your solutions? So this is another thing with this that I want you to understand. Not pink. Okay, purple. So you're going to simplify this 3 pieces at a time. So you're going to do the 3 pieces before you break it down. And then it's going to look like everything we've been doing for the last week. So here, this piece is already simplified here. They plugged in a positive, so now it looks negative. Yes? Then you're going to simplify this piece. And then you're going to simplify, but only what's under the house, not including the house. Yes? So I'm going to show you what I mean. So that first piece, like I said, is already simplified for us. It's just -13 plus or minus the square root of something. What's 2 times 2?
4.
Okay. And then this is what I mean. I'm not going to type the square root. I'm just going to type parentheses 13 squared minus 4 times 2 times -7. See how I did not type the square root? So the square root's still there. Yes? And I have 225. Now, we got lucky on this one. If we would have typed that whole thing in our calculator, we would have gotten an answer because this is a perfect square. if you're ever unsure, you can do the square root, type it in there, and if it gives you a whole number, it's a perfect square. What if it gives you a decimal? Then it's not a perfect square and you have to break it down. Yes? So this one was a perfect square, so that means I can rewrite it. And this is negative 13 plus or minus 15 over 4. Now what do I do? I'm going to separate it. Can I combine everything? Yes, why? Do any of these have radicals?
No.
Do any of them have i's?
No.
Then they are all like terms. You see what I'm saying? They're all just a number. They're all constants. There's nothing behind any of them. Therefore, they're like terms. So we're going to separate. You're going to do once with minus, and you're going to do once with plus. And you're going to figure out your two answers. So alpha y equals enter, negative 13 minus 15 over 4. And that gave me negative 7. And then you can hit second, enter, and that retypes it, and just highlight your minus, whoop, and put a plus. And that gave me a half. So my answer on this one is negative 7 comma a half. Yes? Okay, so that one was an easy one. But do you notice that once we got to this spot, it looks like what we've been doing? Yeah, so once you simplify the 3 spots, it looks just like what we've been doing. Yes? Okay. I'm going to take the silence as a yes. Okay, so look at number 2. Now, number 2 is not plugged in for us, so we're going to actually have to do it ourselves. It doesn't equal 0, but it equals f of x. What does f of x mean? Y. And what do we want y to equal? 0. So I can literally just make this a 0 or make the other side equal 0 and cross it out. I don't care what you do. You can rewrite the whole thing and write equal 0. I don't care. Okay? What's A? What's B? And what's C? Negative 11. Be careful. And then this is where we build our skeleton. These. Like these top pages. Okay, so what is B? What's A? What's C? Okay, and then we simplify our pieces. So what does this equal? Negative 8. What's 2 times 1? And then we type what's under the house. Has anybody typed it? 108. Okay, so make sure you use your parentheses. I'm going to show you something on the next one. If you type just what's under the house, you get 108. Now, is 108 a perfect square? No. 100 is, and then 121, so 108 is not one of the winners. So we have 108. Does 2 go into 108? How many times? 54. 2 goes into 54 27 times. Does 2 go into 27? No. What's our next prime number? 3. 9 times. And then it's 3 and 3. We do. We have 2 pairs. What are they? A 2 and a 3. So I'm going to come down here. I'm going to rewrite it. And I have negative 8 plus or minus. What does this simplify to? 6 root 3. Because remember, you multiply what you take out, so we took out a 2 and a 3. So 2 times 3, and we had that 3 left over. So 6 root 3. Now, one thing I want you to realize, as soon as you realize this 8 over 2 can simplify, we know that we have to separate our denominator. So we're going to separate our denominator, because one of the biggest mistakes I see is people right here will be like, oh, -4 divided, or -8 divided by 2 is -4, and they'll cancel their denominator even though there was a whole other term that had that denominator. So do not simplify until you separate, yes? Okay, so what's -8 divided by 2? Plus or minus, what's 6 divided by 2? 3. And remember, the inside of your house does not ever simplify with your division. The only way to simplify your radical is what we've already done, which is this. Yes? So there's your answer. And we rewrite it once with addition and subtraction, or once with addition and once with a subtraction. I don't know what I was saying. Shh. Yeah, it's okay. I was going to say addition first, but I was writing subtraction, so I just gibberished for a second. Another thing I want you to notice, goodness, do you see that I have the -4 on both of them? Okay, a mistake I saw, God, is that some people would make one of them positive and one of them negative. That doesn't change. The only spot that changes is where you have your plus and minus, yes? So if you have a -4 in front, that 4 stays negative on both answers. The only thing that can change is your plus and minus in the middle. Cool? Okay. Okay, so let's look at number 3. Maybe my English will be better. What do we do? Do we? It's not equal to 0, so what do I need to do? Subtract 3x. And where does it go? The middle. And what am I left with? X squared minus 3x plus 15 equals 0. So one thing I do want you to realize is that you cannot factor this. You couldn't factor number 2 either. So technically before, if this was factorable, how would we have solved this one? A is 1, so would you have typed this one in your calculator? Yes, but this is not factorable because A times C is 15, B is -3. Well, I want you to realize that if the top's positive and the bottom's negative, it has to be double negative. So -1, -15, -3, -5, those are my only factors of 15. Are those ever going to add to -3? So this is not factorable, and the only way you can find your answers in the calculator is if it's factorable. So since it's not factorable, you also are not going to have pretty answers in your y equals. Does that make sense? It would be great. I agree, but it's not. So that's why we have this method. Okay? So let's find our A, B, and C. What is A? B? C. And then we build our skeleton. You are nerds. So B, A, C, A. So I'm going to plug in what I have. Yes. Hold on. We're still plugging in. And we do. We simplify our 3 pieces. So what does that become, Mauricio? Positive 3. 2 negatives makes positive. What does this become? 2 times 1 is 2. And then just what's under the house. So I want to show you this actually. So if you watch, I could type this the proper way with parentheses. Y'all see that? Okay, and I get -51, which is perfect. That's what I should get. But I'm going to show you what happens if I don't type it with parentheses and you just type it with multiplication. So you could do your -4 times 1 times 15. Did it give me the same thing? No, and it's because what it does is it follows PEMDAS when it comes to -3 squared. And it actually thinks of that negative as multiplying by -1. So it squares the 3 and then brings the negative in. So this gave you a -9 instead of a +9 like it should have. So make sure you're using the parentheses just like we plugged it in. Yes? Okay. So what does this tell me I need to do? Almost. What do I need to do first? What's wrong with it? I. Because it's negative, so now I can make it a positive because I put the I. And 51 breaks down, but it breaks down to 3 and 17. 3 and 17 are prime. Do they match? No, so do I get to take anything out? No. Nothing simplifies. Does 3 over 2 simplify? No, and technically this is 1i or whatever. Does 1 over 2 simplify? So does anything here simplify? So do you need to separate your denominator? No. So we have 3 minus I square root of 51 over 2 and 3 plus I square root of 51 over 2. Now if you did separate your denominator, is that okay? Yes, it's the same thing. Just saying you don't have to. Okay, flip to the back. We're not going to do any more of the formula because it doesn't change, okay? There's no point in me doing like 12 problems with y'all because that's it. Yes? But I am not. But I am going to talk about a couple things when it comes to some ugly problems. Like fractions. This is pretty bad. Okay, we can't plug that into our quadratic formula. Okay? But we can make it to where we could plug it into the quadratic formula. How do we get rid of fractions? No. 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 I mean, I guess technically you could, but no. Then you'd make your numbers really big. No, we're not doing that.
Oh, right. Wait, how you get rid of it?
No.
What do you mean, cross multiply?
Multiplication. Not cross multiply. We have way too many terms. Okay, freeze. Oh my gosh. Okay. We need a common denominator. That's what I think y'all were trying to say. Okay, we need to find our common denominator. Technically, we usually try to find our least common denominator, but really in the end, as long as you find a common denominator, we'll all simplify to the same answer. Yes? Okay, so make everything a fraction on both sides of the equal sign. And always find your biggest denominator. What's your biggest denominator? 4. Can 1/4 simplify? No. So can your other denominators turn into the 4? Can 2 turn into 4? By multiplying by what? 2. Can 1 turn into 4? By multiplying by what? 4. So 4 is our LCD. It's our least common denominator. So knowing that, we're going to multiply top and bottom by 2. And here we get 2x squared over 4. I like to put my variables on top because I know I'm trying to cancel my denominator. So I don't like writing them next door. I just put them on top. Bless you. Okay, this already has a 4th, so is that okay? Yes. So I don't need to change anything. How do I turn a 1 into a 4? Times 4, and that gives me negative 12 over 4. Again, times 4. Well, the cool thing about 0 is 0 times a million is 0, so does it change? No, and we can technically say it's over 4, it's still 0, it doesn't matter. Okay, here's my question. What do we do now? Yes, why?
Because you're already calculating.
And what does multiplication do to division? It cancels it. Okay, so anytime you have a common denominator, you can literally cross them all out. Mathematically, the reason you can do that is because if I were to multiply both sides of the equal sign times 4, doesn't that cancel?
Yeah.
So I don't care if you show that step because you know that. So as long as your denominators match, you can cancel them. And now, could you find your A, B, and C? What's A?
2.
What's B?
1.
And what's C? Look at y'all. So smart. You must have a good teacher. It's fine. Okay, look at number 5.
More like the only.
It's because I'm the best. Okay, now what? What do I do first? All the time. All the time first. Oh, no, look at it. Thank you. Gosh, Carlos. We keep you for a reason.
Oh, you're talking about the other problem. Yeah.
I said number 5.
I didn't hear you.
Whatever. Okay, now it's equal to 0.
Yeah.
Okay, they are decimals. We don't want to plug decimals in. But what place value are they in? We're going back to elementary. Tens. How do we know? We're doing a lesson here, okay? You ready? If I give you 0.345, what place value is that? No. Thousands, because 1, 2, 3. You have 3 numbers. And if you have 3 zeros behind a 1, that's 1,000. Yes? So if you have 2 numbers, it's 100. Oh my gosh, look at us go. I'm just such a good teacher. I already said this. I'm just kidding. Honestly, I was terrible at math when I was younger, so I've just found all the things that make it easier to remember. I know. Okay, but it's story of my life. What do we do now? If we want to cancel all of these 10th place, what can we do? Multiply them by what? We don't want fractions. We already decided that. By 10. And what does that do to the decimal? Moves it once to the right. So then would any of them be fractions anymore? To the right. I was right. Then you could, if like one of them was like 0.47, you could multiply by 100, and you would move it twice, and this would become 20. Does that make sense? So whatever the biggest place value is what you would do. So here you have 0 equals, what does that become? What does that become? And what does this become? Y'all are so good. And we get 2, 4, -3. Pretty simple. Okay, look at number 6. We do need a t equals 0. So we're going to subtract 4x from both sides. But we cannot combine that 4x with anything yet. Why? Yeah, we have to follow PEMDAS, and we have to multiply before we can subtract. So what are we going to do now? Not yet. I'm just not going to move it because it's fine. You'll see. We have to distribute, double distribute. 4x times x is 4x squared because of x twice.
But what's the answer?
For which one? I told you we're not going all the way to the answer. We're just talking about how to find A, B, and C because you would plug it into the exact same formula and do all the exact same things, so we're not going to go all the way. Okay. Plus 8x minus 1x minus 2, and I'm going to bring down my minus 4x and my equals 0. It looks terrible, but what do I do now? Combine like terms. What are my like terms? X, x, and x. That has x squared, so that's not a like term. So I'm going to bring down my 4x squared. What's 8 minus 1? Minus 4. And then this 2 does not have a like term, so there's my answer. Can we find A, B, and C now? Yes. So was it as bad as it looked?
Yes.
I'm so sorry. Okay, last thing. We're not going to do number 7 because that one's super simple, right? Because this is your B, this is your A, this is your C. Right? Look, we're already done. A, B, C. We already know it. How would we find A, B, and C in this one? You got to really think on this one. What do we know? Let's get to that piece at the end. What do we know about these numbers on the outside? Think of your formula. Negative, I hate you, plus or minus b squared minus 4 times a times c all over 2a. So what do we know? B is 6. Positive or negative? Positive. Why is it positive? Because it's opposite. What else can we find? What do we know about the denominator? It's 2a. So how would I solve for a now? Divide by 2, divide by 2. What's negative 6 divided by 2? Negative 3. So now we know this, but the sucky part is C is only there, under the house. But we know that under the house equals negative 84. So can I plug in what I know for under the house? Okay, so we know b squared minus 4 times a is negative 3. We don't know c. And we know that this equals negative 84. Right? Because under the house is b squared minus 4 times a times c, and it's also negative 84. So can we solve now? What's 6 squared? 36. Minus what's negative 4 times negative 3?
12.
Positive 12, so I'm going to change that to a plus. Don't forget your C. Equals negative 84. Now what? Subtract 36. And I'll save y'all time. It equals negative 120. Now what? Last step. And what do we get? Negative 10. So there is our A, B, and C, which would be negative 3x squared plus 6x minus 10. Yay! I was so smart.